We know that a sequence is a list of terms or numbers. So an example of a list of terms would be 3, 8, 13, 18, and 23. That's our list of numbers. So notice this list of numbers has commas in between. We have another term called series. And this is the listing of numbers with a plus in between. So that would be 3 plus 8 plus 13 plus 18 plus 23. So can you share what is the sum of this series? There's different ways you could do it. You can throw that in the chat. What is the sum of your series? Nice job. Got one person to have it. Only one. All right, there's another. Good work. Knew you could do it. All right, so the obvious way to do it maybe would just be to say, what is 3 plus 8 plus 13 plus 18 plus 23? That's the quick way to do it. Because we only have 5 terms, we don't have to worry about typing in such a large list of numbers. We could just add them together. We also have a formula we could use. We know this is arithmetic because our terms are going up by 5 every time. Our common difference is 5. We can clearly see that the number of terms is 5. And our first term is 3, of course, and our last term would be considered 23. So if we were going to find the sum of the terms, sum of the series, adding up all these terms together, we would use our formula. The number of terms times the first term plus the last term divided by 2. So we know the number of terms because there are 5. First term is 3. Last term is 23. So that's 5 times 26 divided by 2. That's 5 times 13, otherwise known as 65. 65 is our sum of that series. What's the summation notation for this series? This would be a little bit harder to put in the chat, but you got any idea? So our summation notation, we need to know the rule of the series. How do we determine a rule? Well, the explicit rule for an arithmetic would be right there. We know that our first term is 3 and we're changing by fives, we're not looking for us to put in our number of terms in here. We just want n because we want to be able to calculate it for any of the positions. So a of n equals, you cannot add these together. So that's 3 plus 5n minus 5. Our rule is 5n minus 2. There's the rule of the series. So when you have a rule of the series, then we use our sigma for sigma notation. And we use our 5n minus 2. The value that goes on bottom will always be a 1, because when you're using the explicit formula, that's implying that when you plug in a 1, 5 times 1 is 5 minus 2 is 3. Plug in a 2, 10 minus 2 is 8. And you can keep going up, 1, 2, 3, 4, 5. Plug in a 5, you get 25 minus 2 gives you 23. So we're going to be going all the way to 5 to get each of our terms. So that's our sigma notation, and this would actually equal 65. So we're going to try our list of numbers. We'll take 17, 11, 5, and negative 217. What is the sum of that? And don't tell me 184. Right? So what we're going to need to focus on is that these numbers are changing by negative 6. So we know this is arithmetic. And our common difference is negative 6. We know the n, or we're looking for n actually, right? We need to know what n is. We know what a of 1 is. We know what a of n is. But what we don't know is how many terms does it take to get up to that point. So since this is arithmetic, we can use our formula. We need to know the number of terms. So this is 217 equals 17 minus 6 and minus 1. We could minus 17 across. To get 234. And then when we divide by negative 6, that gives us 39. And add 1 gives us 40 terms. So we have 40 terms. Now we have the 3 bits that we need to know. All right, so our summation is 40 terms. our first term is 17. Our last term is negative 217 divided by 2. Couple different ways we could do this. We could divide by the 2 first, if you like. 17, and that would be negative 200. 2 times 2 is negative 4, and the zeros would make 4,000. All right, everybody. That's what we've got today. Right. I'll see you tomorrow. Ciao.